Hey everyone, here we are talking about the rock cycle, and this type of rock we're going to talk about today is called igneous rock. Igneous, igneous rock. That's what teachers would call a tier 3 word. It's a word you would never use unless you're in the classroom. Even me or your teachers, we don't go around with our families and friends and say, "Oh, look at that igneous rock there." No one talks that way unless you're a geologist who studies rocks. And someday one of you might be. It's a very rewarding profession, very lucrative profession. A lot of geologists are used to find fossil fuels, which I don't find particularly, you know, interesting because fossil fuels are finite, they're not renewable. However, geologists, really good study, and I don't know many geologists who aren't super bright people, so geology is a good field to study. Anyhow, igneous rock. Igneous rock is a real dynamic sort of rock that's going to form where we have seafloor spreading, right? Remember the seafloor in the Atlantic? It's like a big seam that goes around the earth like a seam on a baseball. And out of that seam we have the seafloor coming apart, and when the seafloor spreads apart, magma comes up. It's magma in the earth as lava when it hits the air. So it's magma down below the surface, below the crust, and then it's lava when it hits the water or the air. So igneous rock is going to form either on the seafloor or where volcanoes erupt, or in these third types of things where volcanoes don't make it through the surface of the earth, but they just kind of like mound up, and they make this thing called a pluton. A pluton's like a rounded ball, and over time the pluton will get exposed because what happens is the layers above the pluton, which kind of solidified underneath the earth, will get exposed due to erosion above it, and we have mountains like El Capitan, Devil's Tower in South Dakota, which is a really highly venerated spot for Native Americans. This is made of basalt, and basalt is a type of igneous rock which occurs when magma cools down, and that's what the seafloor is made of, basalt. And basalt looks like this. It's a black rock, super shiny. Obsidian is also a rock that occurs usually where volcanoes erupt. Obsidian is was used for surgical tools, used for arrowheads way back in the day when we were hunters and gatherers. It's a shiny black rock, and it can be struck at a certain angle to make a super sharp edge. You could use it as a razor blade to cut. You could take the fur off of an animal and cut underneath it so you had like a coat or a shelter above you. So obsidian is a type of rock that comes out of a volcano. Basalt comes out of the seafloor. Same type of color, really fine texture and black. So let's take a look at the some of this metamorphic rock that we melted as crayons. This metamorphic rock, if it doesn't solidify and re-emerge, it may go into an area of a subduction zone where we have one plate riding over another, and the other one kind of like goes below it. And when you have this sort of subduction, what happens is that plate, as it subducts going down, 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 deeper into the earth, is going to that spot again where we have a lot of heat. So the deeper we go into the earth, the hotter it gets, the rock liquefies, and sometimes that rock wants to come back out. Now when that rock comes back out in a liquid form, it's called magma. Remember? It's liquid form in the earth, and it's magma up above. So I have my crucible here, which is still hot, so I'm going to use my sleeve. Really should have a glove. So I have some aluminum foil. I'm going to pour this, see if I can get it on the camera for you. Pour this out into the tin foil. Okay, and these are 4 different colored crayons that represented different things, different types of rocks and minerals and gemstones. And we can see what happens is, just like lava, it like any liquid or gas, it's going to take the shape of its container. So this so-called lava now, which would be on the earth, is taking the shape of the tinfoil that's on my desk. And we'll see what happens when it cools down. I don't know if you can see that, but you can see it rapidly cooling, and that's exactly what igneous rock does. It's cooling from the outside in. If you want to eat your soup and you're really hungry, eat it from the edge of the bowl because the heat is leaving the bowl into the room. Okay, same thing with this crayon. It's going to return back. It was in a solid state. It went to a liquid state when we melted it. Now it's returning back to a solid state. And if we weighed the crayons before and then we did it after, we'd see that the mass is the same. It didn't gain or lose any mass, but what it did, it changed its form. It went through a physical change, but then it kind of cooled back down, and now we're kind of have it again as a crayon you could probably draw with this thing. So I'm going to let that cool down and we'll check it out. Okay. The physical change occurs when you break something down, but it doesn't change its real properties. If you split a piece of wood in half, it's still wood. You have two pieces of wood. That's a physical change. A chemical change is when, say, you burn a piece of paper. You can't reclaim that back. You burn a piece of paper, it turns to heat, light, and ash, but you can't get those things back together. Now, they don't disappear. They go out in nature. The heat would rise up, the ash would fall to the ground and maybe provide nutrients to plants, and the heat would go into the atmosphere. But it never leaves Earth, okay? Energy can't be created or destroyed. So we're going to let this this crayon represent our igneous rock, okay? So igneous rock is going to occur sort of like in a subduction zone, and after it cools down, what we have, is a nice sort of glistening, hard and sharp-edged material, okay? And you'd be really surprised at the metamorphosis that occurs with rock when it goes through a change in heat. Now, what I have here is a piece of lead. Okay, this is a piece of lead. They use this on the side of roofs. Super soft metal. It's an element. On your table, of periodic table, the symbol for lead is Pb, which is where they get the word plumber, because plumbers used to use lead all the time to join pipes. Now we use plastic called PVC. I'm going to use this torch here, butane lighter, propane torch, okay, these different tanes. I'm going to ignite this torch. You can see that flame there. Okay, that's good. Now, let's see. I have with me a pair of needle nose pliers. I'm going to get this pestle here, mortise here, and we're going to heat up this lead, okay? This heat is going to represent, deep down into the mantle. This lead, which is a metal, is going to go through a physical change, okay? Let's see what happens to this lead. This is the sort of metal that you use when you go fishing. Can you see it? It has a really low melting point, and it's dripping into this little crucible on my desk. You can see it's still on fire. Now, a good scientist, which I won't claim I am, would have weighed this metal beforehand, and that scientist could prove to you that once the metal is melted, cooled down, and reweighed, the mass would remain the same. I'm going to turn off my little torch there, and we'll take a look inside the crucible here. You can see all this wax. I should have cleaned that out. There's a crayon in there. But again, this igneous rock is formed when you have a lot of heat and pressure, and that liquefied rock is going to come out as what we know as magma in the earth as it changes from solid to liquid, and then lava when it comes out. Now, when that lava cools and solidifies, it turns back into a solid rock again, and the solid rock is examples of solid rock that are igneous rocks are basalt, which is on the seafloor, and then obsidian, which is usually found around volcanoes. So to really quickly review all the three different rocks in the rock cycle, you have sedimentary rock. That sedimentary rock is found where you have rock layers. The rock layers can be separated apart. Sedimentation occurs when you have deposits of sand, okay, or shells and calcium carbide settling down in the ocean or lakes. And when they do settle down, sometimes animals get trapped in there. And in sedimentary rock, we find fossils. Okay, the metamorphic rock is that rock that goes through a change under heat and pressure. You get any type of rock, you mix them all together, and what you get is this kind of a conglomeration. Con means with, so all the rocks are with each other, they're together, and we have a type of rock that kind of like looks like this. It's speckled. It's kind of like having a dog that you don't know, its parents. You call it a mutt. We don't know if it's a Labrador or a Doberman. It might be 7 different breeds of dogs. People like that too. I'm English and Italian, and my kids, if they meet another person and they're Dominican and Czechoslovakian, now you have 4 different sort of nationalities represented in one person. So we go through a sort of metamorphosis, as humans, but not as a species. And the last type of rock is that igneous rock that we just talked about. So just to review real quick, have a poster here. We have our rocks and minerals. We have our igneous rock over here that we just talked about. The igneous rock is from the volcanoes, okay, you can see up above, or seafloor spreading. On the other side, we have our metamorphic rock, which is that rock that goes through all kinds of changes. And I use that word conglomeration. Conglomerate is a type of rock, and if you look at it, it has all these different things together. It looks like someone made mashed potatoes with peas and carrots and celery in it. And it's all this stuff mashed together, mixed together. And then the middle type of rock is that metamorphic rock. Remember, metamorphic rock here is that sort of rock that goes through the heat and pressure and changes in a big way. Okay, so that's it for the rock cycle. We have all 3 types. Hope the video was helpful. I know it's not as good as what you've been seeing by your teachers, but we're doing what we can, people. All right, be good.